Here we go. So today we're going to talk about special right triangles. 9.2. I need you to open your student journals 249. Here on page 249. You take a look at that. I want you to read about 45, 45, 90 right triangles and 30, 60, 90 right triangles. Make any notes you need. Okay, can I have your attention back up here? 45, 45, 90, 30, 60, 90. So these are triangles you're going to use throughout the course of the rest of this year. But when you get to advanced algebra, next year you're going to use them when we deal with the trig functions. And then when you get to math analysis, you're going to use them quite a bit because a good chunk of that course is dealing with the trig functions. Okay, these are numbers or ratios. These are different relationships that you want to keep in mind. All right, so when you're dealing with a 45, 45, 90 triangle, and you have a side length, a leg of x, another leg of x, we get a hypotenuse of x root 2. Okay, and when you're dealing with the 30, 60, 90, you have a leg length of x and another leg length of x root 3. The third length is 2x. Okay, those are your relationships. So everything's kind of dependent on x. What I'd like you to do is somewhere, wherever you have room for notes, either there or on a separate sheet of paper, you probably just draw it under the notes section there if you want. I want you to first sketch for me a triangle that is a triangle looks like that. Okay, under 30, 60, 90. Under 30, 60, 90, I need you to try a triangle that looks like this. We're going to label this. We're going to start with 30, 60, 90. We're going to label that 60, 60, and 60. Now, given that triangle right there, I want you to create two 30, 60, 90 triangles. Okay, hopefully you're able to just kind of break this right down the middle there and recognize that that makes that a 30. Okay, and that a 30. Okay, when you have an equilateral triangle, which the 60, 60, 60 is, this right here has a length of, if I call it 2x, what would this length be down here? 2x. And what would this length be? Okay. Gino, I don't trust you right now. Do you know why? Every time I look over there, you're talking, and then when I look over there, you look at me like you're doing something wrong, and you stop talking. It's like when my dog has done something wrong, and I look over there, and he's like, kind of giving me that weird stare. That's what you're doing right now to me. Okay? Not saying you're a dog. I'm just saying. You're kind of freaking me out now. All right. So if it's that you're just talking, then I need you to stop talking. Okay? So look, if I've got the 2x, 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 and I erase this chunk of the triangle, I now am left with a 30, 60, 90. And rather than having 2x on the bottom, I'm left with just x. Okay. Good. That's how we get that relationship. Now, if that's x and that's 2x and this is a right triangle, how can I find my third length? What's that cool theorem we used earlier in the semester or earlier in the chapter? Carla? How about, let's start with, yes, we'd use the Pythagorean theorem. It's not quite 2x minus x. It would be, so it'd be x squared. If we called this b, okay, I want you to use the Pythagorean theorem and find out what b is there. Everyone good there? Make sure when you square this, you get that, right? You have to square both parts. You can't just take the square root of everything. We talked about that last week. You have to add those two for square them and add them. Subtract your x squared. B is equal to 3x squared, the square root of that, which b then is equal to root 3 root x squared. We can break those apart. How many remember all these algebra skills? Good. What's the square root of x squared? X. And the square root of 3 is just root 3. Okay. And so really the way we write that is b is equal to x root 3. Okay. Which is this side. Which is exactly what we have here. That's how we come up with that relationship. Notice that their triangle, we'd have to turn that way if you want it to kind of look like ours. But our isosceles triangle, or our equilateral triangle, if you draw in that extra piece, is like that. Okay? You know what, I was going to do something with this one. I think what I'm going to have you do is just, I want you on your own paper here, let's just, rather than having that two-sided one, let's just take the portion of that. And since we've already went through the process on that other one, if I tell you that this is x and this is x, this is an equilateral or an isosceles right triangle. Okay? And I use the Pythagorean theorem, a squared plus b squared equals c squared. What side is this right here? This is c. Okay? So that would mean x squared plus x squared equals c squared. Tell your neighbor how many x squared you have. You're good. 2x squared equals c squared. Gino, you know what I do next? Almost. Get rid of this. I have to square root it. Good. Square root of it. Nice work there. And then, anyone know what I do next? Carlo? Good. So you take the square root of 2 and you break them apart, which gives you the root of 2, and the root of x squared is x. And so c is equal to x root 2, which is how we come up with that one. So really we're just using the Pythagorean theorem. So please keep in mind, if you cannot remember these relationships, you can always use the Pythagorean theorem. However, I will tell you that there are times they're only going to give you one side. And you can't use the Pythagorean theorem if you don't have two sides. So you're going to have to remember a part of the relationship. Hopefully you recognize that when it says 45 and 45, that these two sides are the same. The tougher part will be if they give you that measure and you have to find those two sides. Okay? This all comes from the Pythagorean theorem. Yeah? Uh-huh. Yep. Always. Yeah, this side will always be twice that. Okay. So the hypotenuse will always be twice the shortest leg. You guys, the way I remembered them when I was in school, I still remember them that way. Probably because I learned it that way. Is I always remember, what's the coefficient here? What number's in front of x? 1. That's called a coefficient. Okay, what's that called? Coefficient. Learn that term. You're going to eventually read it in a book when you're studying math and you don't have a teacher sitting by you. Okay, that's 1. So count with me.
1, 2, 3.
Yeah, 1, 2, 3, right? 1, 2, 3. Okay?
1, 1, 2.
Okay. You have 2 of the same thing. That goes with the 2. That's how I remembered them. This is 1, 2, 3. Yeah. Hold on. Don't give away the movie here, Carla. Let's turn to page 250. Thanks. Okay. So that would mean, I think Carla's trying to make sense here. Why don't you try 1 through 4? On page 250. All right, here we go. Person number 11. Who's number 11? All right, Brendan, that's you. You get a chance to earn a point for your team. What did you get for number 1? Oh. Oh, I was going to give it to you. Who is 11? Jordan. Yeah. Is it 10 square root 2? That's x. That's x, and this is x root 2. Now, it says x and x root 2. I know that's kind of weird, so I might just call that y for a minute to make it easier. Hey, I have 3 equations right now. I have x equals 10. This is also equal to 10. And this is x root 2, which if x is 10, that's 10 root 2. Jordan, did you say 10 root 2? Hey, you're correct. Jordan, you get a point for your team. Nice job. So, what you want to do is you want to start setting up equations. So first you have to recognize, hey, that's the same and that's the same, meaning that this is a 45, 45, 90 triangle. And the legs of 45, 45, 90 are equal to x. The hypotenuse is equal to x root 2. Now, once again, I know it's weird if that says x, and so I'm just going to call that variable y to make it less. Notice this has 1 variable. It tells you what x is. This has 2 variables. You need to know x before you can solve it. Well, good thing you know x. X is root 2 over 2. Therefore, y is equal to root 2 over 2 times root 2. What is root 2 over root 2 times root 2? Okay. What's root 4? Is 2. Ian just got a point for his team. Well done, Ian. Okay. And all right, that one's 1. Okay. Go ahead and figure out 3 and 4. Questions? Yeah. You could. Which is 1. Okay, let's talk about number 3. All right. Number 3, let's go with person number 30. I don't think we have a 30 in here. Okay, number 7. He's not here. Number 24. He's not here either. Number 29. He's not here either. Number 7. Not here either. Number 12. That is you. Hey, this is equal to x root 2. Right? And you said it was what? Yeah. That means x equals 8. Well done. That's a second point for that group. Nice job. Okay. Hey, I'm using the random number table. Sorry, it's a random number. Just randomly picks numbers. Okay? Number 4. Number 4 is a little tougher. Okay? So, let's start out with this. Person number 1, what's this side?
X.
X, nice job. Okay? Yeah.
You get a point, boy.
They get a point for saying X. Okay? Number 4, what's this side? 12, what's it equal? It does equal x root 2. Okay? Nice work. Okay? Person number 1, it's random. Random. Random.
Let's go. All right, you gotta get this.
Random. Why would I hate you guys?
Because I'm on this team.
Maddie, that would not be true. Come on. That's not true. Okay. So, person number 1, what do I do here?
Would you plug it into the Pythagorean theorem?
I'm not going to put in a Pythagorean theorem. First volunteer to raise their hand, tell me what to do. Yes, Carlo. You could divide by the square root of 2. Now, I just want you to know there will be another opportunity for points on this here in a minute after we finish this problem. Okay, when I divide by the square root of 2, I get x equals 12 over root 2. Okay? Now, if x equals 12 over root 2, that is not proper form. Why is that not proper form? Yes, KJ? The radical cannot be on the bottom of a fraction. Therefore, how do we deal with that? Danica? You square? No, not quite. Oh, too many hands went up, Eric. I don't know what to say. 17. Who's 17?
Me.
Okay,
you times the top and the bottom by root 2.
Yes, you multiply by root 2 over root 2, which we call the special number 1. That gives us 12 root 2 over 2. Okay? Yes, Carlo. No. Okay, Brendan, what do I do next? Brendan. Simplify. What's that become? 6 root 2, yes. Okay. X is equal to 6 root 2. What does x equal? Yeah, it equals 6 root 2. Okay? All right. Now, with that being said, there is another way you could have solved this when you had x equal, or x root 2 equals 12. Rather than dividing by root 2, there is another thing you could have done. Does anyone in here know the other thing? Yes, Maddie?
Wait, couldn't you have,
Yes, wait, couldn't you have, squared it? Yes, you could have, squared it. You could have actually squared it. Okay? And when you actually square it, Maddie, what do you get on this side?
I did it wrong.
What do you...
144.
144, and what do you get on this side?
2x. And then you get x squared times 2.
Yes, you get 2x squared. Okay? And then, what do you do?
I divided by... Do you divide by 2?
You do divide by 2. And then what do?
You have to square it, or you have to put it in the square root thing.
You have to put in the square root thing. Okay, also known as take the square root. And when we do the square root thing, you get root 36 by root 2, which gives you 6 root 2. You could also go that route. You're good? All right. Questions? The score we will get to. The score right now is Jordan, your group, has 2 points. Nathan, your group has 2 points. This group right here has 3 points. That group has 2, and that group has 1. Okay. Carlo, question.
So, what's the square root of 72?
It's 6 root 2.
Yeah, but what can you say in decimal?
You can if you're going to talk for the rest of your life, which, Carlo, I think you could probably do. However, we're not going to right now. Okay? You would have to keep going on forever and ever and ever. It's an irrational number. Okay?
No, it would have to end at
No, you're not stupid. It's a good question. I'm just saying we're not going to listen to you talk for the rest of your life. Okay. Number 5. Off you go.
15 root 3.
Okay, now I will tell you guys, as you're starting to work through these, it's helpful sometimes just to draw the picture so you can list the ratios. It doesn't even have to be an accurate drawing. That's x, that's 2x, that's x root 3. Okay, that's when you're dealing with your 60 and your 30. 30, 60, 90. Now, it's just nice to have that picture to reference. And please note, it also says write your answer in simplest form, which means we cannot go decimal form for us decimalites out there. Hey, if you think decimal is simplest, just to have that argument, if you want to race, I want you to multiply that together without your calculator. Okay, not your brother.
Not your brother.
I win.
I win.
Okay, that's the fastest.
Oh.
All right. Now, let's go back to this. If we are labeling these, please note that the shortest side we call x. The longest side we call 2x. And the other side, the other leg, we call x root 3. Now, I'm not going to make, this already says x, so if I say x equals x root 3, that's really weird, so I'm going to just call it z for the sake of what we're doing here. Okay? Which means, when I'm looking at this picture, there are 3 different parts. Which one helps me solve? Andrew?
X equals 15.
X equals 15. Well done. Got a point there. Okay, if x equals 15, now that's not the value of x they gave us, right? It just means that's 15. What does y equal? Yes. Y equals 30. 2 times 15. So y equals 30. Okay, well done. Okay, and that means z equals, yes, Carlo? 15 root 3, even in radical form. Carlo, you're becoming cooler by the minute. 15 root 3. Totally radical, man. Okay? All right. Hey, at least you understood the joke. Impressed. Huh? A point for what? Understanding? You get a point for answering the question. You might lose a point for laughing without finding humor in it. Okay? Number 6 and 7. Make sure that you give those 2 a go. Label them first. It'll help you out. Okay, here we go. Person number 26. 26. What is this side length? Who is 26? Go for it. 2x. Well done. Okay, and number 30. Number 9. What's this? We're going to call this z. What's this side? Who's number 9? We don't have number 9? All right, we'll move on. Number 9, again. Number 4. X root 3. Well done. Okay. And number 2. Okay. Number 22. Yes. It is? It's x. Okay. And which means person number 1, which one of these 3 equations can I solve? Which one can I solve? I have 22 equals 2x, y equals x, and z equals x root 3. Which one can I solve? This one? Can't solve that one.
Oh, no, you can solve number the 22 equals 2x.
Okay. So what's it equal?
It equals 11.
It equals 11. And now I take that 11, and where do I put that 11? Yes, Abdul. I put it in for y.
Wait, what?
Yeah.
Put it extra 3.
Good. So y equals 11. Well done. All right. And the third side, person number 13.
Get it wrong.
I got it.
Z equals 11 root 3 because x is root 5.
Very good. Z equals 11 root 3. Well done. Plug that in right there. All right. So, just a quick update on the scores. Last problem. By the way, you can lose points for talking trash to other teams. Okay. Person number 10.
You guys can all do it. Good luck.
What is this side length? Person number 10. Yes.
Well, I'm not number 10. I'm using my hand for all the teams.
Sure, go ahead. Number 10 doesn't want it.
I'm going to say that side is x root 3.
That side is x root 3. Okay. And person number 1, what is this side length?
2x.
2x. I'm sorry. It's a random number table. Okay. Which of those three equations can we solve? Oh, let me pick some. Person number 26. Yes? 9 equals x root 3, and what does that equal? Everyone agree? 3 root 3?
Yes.
If you square this side and square that side, you get 81 equals 3x squared. You get 27 equals x squared, and then you get x equals root 27, which is 3 root 3. Okay? So x is 3 root 3, meaning x is 3 root 3. No. Okay? And y is? Wow. Oh, that was too difficult. Number 19.
What?
Danica. Oh, Danica wasn't paying attention. She's doing something else. Number 7. Isaac's not here. Number 30, no. Number 22 is Gino. 6 root 3. How'd you get that, Gino? All right. Unfortunately, Gino doesn't get the point. Person number 10, Amanda. What is X? Or what is Y? You don't have that? Okay. Person number 8. All right, volunteer. Lexus.
Y equals 6 root 3
What?
because you multiply x by 2.
You multiply x by 2, so you get
3 root 3 by 2.
y equals 6 root 3. Multiply, oh, you guys didn't even see me do that. You multiply x by 2, so 2x equals y, so 2 times 3, root 3. There we got it. Okay, any questions on it? Yes?
Why don't you multiply the square root 2? Why isn't it 2?
Because your square root represents a number, and this is saying that 2 out in front of it says how many of those you have, or that 3 out in front of it says how many of those roots you have. You have 3 of them. So when you double it, you would have 6 of those, right? So you only have to multiply by the outside. Okay? Question? Turn the page, 251, number 8 and 9. I want you to go ahead and work on those two. Okay, we're going to go through number 8, 9, and 10 tomorrow at the very beginning of class. You need to finish those 3. Make sure you draw a picture to help yourself out.